All right, so let's talk about binary and the connection with binary that you guys noticed yesterday. So we're going to make 5-digit binary numbers, and orange blocks are going to be ones, yellow blocks are going to be zeros. Okay. The fifth row of Pascal's triangle goes 1, 5, 10, 10, 5, 1, and that represents 5 things. Pick one way to pick 5 things out of 5. 5 ways to pick 4 things out of 5.
Yep.
10 ways to pick 3 things out of 5. 10 ways to pick 2 things out of 5.
5 ways to pick
5 ways to pick 1 thing out of 5, and 1 way to pick 0 things out of 5. Okay. So let's look at the connection with binary. How many 5-digit binary numbers are there with all ones?
Well, there's just one.
Okay.
All ones.
All right. What 5 things were we picking out of 5 here?
We're picking 5. We were picking 5 out of 5.
Okay. What 5 things were we picking though? What are we picking here?
We're picking digits for we're picking the digits for our 5-digit binary number.
Okay. And what did we slide in here?
Well, all ones.
All ones. We're picking where the ones go. Okay. There was 5 slots, and we needed to pick 5 ones for those slots. And how many ways were there to do that?
Well, just one.
Just one.
One.
Okay. What if we wanted to pick 4 slots for the ones?
Well, that would be the same as filling in all ones and then replacing one with a yellow.
And then there's 5 spaces to put the yellow.
Okay.
So there would be 5 ways to do that.
5 ways to pick 4 slots for the ones.
Cool.
Okay. So how many 1, 2, 3, 4, 5-digit binary numbers are there that have 4 ones?
5.
5.
Because you just have to shift the 0.
Yeah, and then here we're counting this as being a valid number, even if it begins with 0. That's a 1, 2, 3, 4, 5-digit number.
Yeah.
Now we have to pick 3 slots for the ones next.
So we would replace that.
Okay.
Well,
How many ways are there to pick 3 slots out of 5 numbers?
Well, let's see. If you fix this in place, then you have 4 spaces for this to go.
Okay.
And if you move it up and fix this one in place, you have 4 slots. Then you can keep moving it up, so you have 5 times 4, which is 20, but this and this are the same as this and this.
So you're overcounting.
So you divide that by 2 and get 10.
Okay. And is there a way of thinking about this where we had to pick, when we're looking at 5-digit binary numbers with 3 ones, is there a way of looking at this as we're picking 3 slots out of 5?
Well, you could say you have 5 slots for the first one, 4 for the second, 3 for the third, then divide that by 6. Well, yeah, but if you divide it by 6, then you correct for the overcounting.
Okay. But you're calculating, you keep calculating 10. I want you to see what 3 things are we picking here out of 5.
We're picking 3 ones.
We're picking the slots where the ones go. Okay, so I shouldn't have filled in ones there. We're picking the slots. We need to pick 3 slots out of 5, and it turns out there's 10 ways to do that. Okay, so here we picked all 5 slots. Here we're picking 4 slots. Here we're picking 3 slots. Now how many ways are there to pick 2 slots for the ones?
You could think of it as
picking 3. You're picking 3 slots for the zeros.
Yeah.
And that would
So
be
it's
the same
way.
So that's interesting. So now you're starting to see some of the symmetry.
And then it would be the same.
Picking the slots for the ones and picking the slots for the zeros has to be the same.
So and it's also the same for here, and then there's one that's all zeros.
Now, here's the thing. Have we counted all of the possible 5-digit binary numbers here?
Well, we've done all of them with all ones, 4 ones, 3 ones, 2 ones, 1 1, and 0 1.
Okay, so did we hit them all?
Yeah.
So how many 5-digit binary numbers are there?
Well, let's see. So 20, 30, looks like 32.
Okay, and you did that by adding up the row of Pascal's triangle. But how can we see there's 32 5-digit binary numbers just right off the bat?
Well, because we could add up the digits if we replace all ones, we can add up the digits for that. We can't add up because the biggest number is 31.
Yeah.
Because then we would have an extra digit, and the smallest number is 0.
So
There's 32.
there's 32.
Or you could see that you have two choices for what you put in each slot.
Yeah.
There you go. Which 2 to
32.
the 5th is 32. So this teaches us the connection between binary numbers and Pascal's triangle. And what is the connection?
Well, it's Pascal's triangle you can use to pick stuff.
Okay. Where's the power of 2 hiding in Pascal's triangle?
Well, if you
it's
add,
the row, it's the sum of the row.
and the row number matters too. If you call the first row 0,
Yeah.
That's 2 to the 0.
which is 1,
So it looks like the nth row of Pascal's triangle adds
Is-
up to what?
2
2
to the n.
2 to the n. It's just a simple counting argument. Do you guys want to check that, or do you believe it?
I believe it.
Do you believe it?
Yeah.
Okay, cool. We don't need to check it now. But that's the amazing connection.
Yeah.
Pretty cool, right?
Yep.
All right, good work this morning, guys. Good work.